All right, so hi everyone. We're back with another video today for Swix. Tom, how are you doing?
Yeah, I'm great. How about yourself?
I'm good. So I thought today it would be interesting for people to hear some of the past experiences we've had with weird HTTP oddities that we've seen, like, very unexpected, right? Like we're kind of doing things the way we want to, and it's like sometimes just doesn't work for some reason.
Yeah, because we make a lot of HTTP requests to like a lot of different servers, which we don't control. It's not like, when you make an API call, you test it out, you see something breaks, you can fix it. Like customers add their endpoints and try things out. So we see a lot of these oddities all the time. We follow the spec, or again, at least like used to follow the spec fully. But nowadays we've adjusted our code to really follow, all the oddities that you see in the wild. Um, yeah.
When you say like oddities, like and that we've adjusted the code for it, it's essentially instead of like following it to a T, it's like we've kind of like loosened some things around to
Exactly.
account for the kind of how do you say character that some people put in their code.
Yeah, I mean, it's kind of like there are two parts of it. First of all, even if you operate within the spec, like what you're doing is allowed, but it's kind of like out of the normal path. That may trigger other behavior, like other servers to not like what you're doing. And then the other part is them doing something that is, or requiring something like in a very specific manner, or doing something that is not allowed, but you have to say, well, even if it's not allowed, we have to follow it, right? We have to, or at least like gracefully handle it. And I'll give some examples in a moment. Actually, would you like to just jump into examples now?
Yeah, just jump into like what is like.
Yeah.
I guess like usually I like to start off like what's like the one that like you remember the most that was just like the biggest pain in the ass, I guess.
Oh man. Oof. I don't know. That's a hard one. Well, okay. I mean, let me let me start. I don't want to pick favorites. Let me start with the first one that comes to mind.
Or wait, what's the opposite of a favorite?
Yeah. No, but I'll just start with like the first one that comes to mind, and then after I give through all of them, like remind me again. I'll try to pick the
All
worst
right, I'll
one
make
I've
you
just
pick at the
covered.
end.
Yeah, like maybe I don't know. Let's try. So I guess like the first one that comes to mind, and we've seen it a lot in the beginning, is case sensitive headers. So per the HTTP, one or at least 1.1 like spec, headers are case insensitive. That means that if you send a header called authorization, it can be all in lowercase, all in uppercase, mixed, whatever. Um, and like the server should acknowledge and like, understand all of them. The problem is that it's not always the case. Some frameworks or some libraries don't normalize, don't like put a canonical form before bringing it to customers, or don't use like case insensitive libraries for like when dealing with headers. And that means that even the slightest change to the header name can cause a break, can cause them to not recognize that authorization is actually authorization. It's actually in HTTP 2, they fixed it by just requiring that all the header names are lowercase. But in HTTP 1, it was very common for people to use, upper, I guess like Pascal case, sorry, but that's probably the name. So like upper camel case, but with uppercase in the beginning. That was the common thing to do. And we see it a lot. Like you pass the wrong, like you have to make sure that you preserve the header capitalization or the casing, even when, it really doesn't matter. So that's like one example. But I think that's a common one. I think like other people have probably encountered it before. Does that make sense?
Okay. Yeah, yeah. I mean, now that you mention it, I think most of the headers that I've come across have been like capitalized, especially
Yeah.
authorization. That's one that comes to mind. Yeah.
Yeah. For whatever
I
it's
actually
worth.
don't think I've seen a lowercase one. Now that I
Yeah.
think about it.
Yeah. I mean, for whatever it's worth, for Swix, like in the docs, we've had, and maybe we still do, like reference some of the headers in that, like in the Pascal case. So like uppercase letter, and then like, camel case. But in code samples, we use lowercase. But it's kind of like, just like it's easier. Authorization starts with a capital A, right? And like it's kind of like it's easier to just follow that.
In the one, it looks better.
Yeah, exactly.
It's
It looks much better.
authoritative. You need the
Yeah.
capital A.
Yeah. So I mean, that's why people follow it, and people should, and I do it as well. But like please lowercase, or like make sure that you lowercase when you actually deal with headers. Yeah, and most frameworks should deal with that. Cool. I'm just like trying to think. Yeah, exactly. I'm trying to think like as we're going along, what is the worst one? But okay. The next one, which is like a bit of a funny one, is invalid header names. So as we just talked about the capitalization or like the casing of headers, but even though that doesn't matter and headers are case insensitive, there are some characters that are just not allowed in header names. One of them would be a space. And you could have a server that, like you make a call, like you make a beautiful call, you send it to, send it to the server, and then you get back an invalid header. What do? Do you fail? Do you say like it's a bad thing, or do you just like ignore it and carry on, or what is the right place? What is the right thing to do? And for whatever it's worth, what we've chosen to do is just ignore that bad header because we really don't care about those in our code, like in the Svix world, because we just send the webhooks. But like some libraries, for example, Hyper in Rust doesn't like it and just like will fail. We'll just say, well, that request is just bad. And, we had to make sure that we walk around that.
Oh, okay. So even though it's Svix, we were kind of like a little lax with it. We kind of recognized it's not like a critical component. If you're using some dependencies that are stricter. Yeah.
Exactly. We don't care, but we're using a dependency that was strict, and that was causing us issues. So we had to like make sure to to lax it a bit in its requirement. Yeah, it's a funny one. Like you think you live in a perfect world. Like everything is everything is correct, everything is up to spec. But usually when you deal with variety of implementations, especially with the web, that everyone implements their own like web server, like load balancer, like all of those like different frameworks. And there's just so many different implementations out there, and you have to be aware, that. Yeah,
and it's like a design decision, kind of upfront, right? Like, how can we design it to be flexible, almost?
Yeah, to be lenient, I guess is a better word.
Yeah, that's a better word. Yeah.
Yeah. So that that is I think like many people are probably not going to encounter that because what's both nice, what's both good and bad about the Rust world is that everyone is very pedantic. Like people care a lot about correctness. So the Rust libraries tend to be like very assume that the world is clean and everything is perfect. And you have to make sure to kind of like, okay, no, actually there are oddities in the world. So like, please allow this, accept that. But in Python or JavaScript, it's probably, JavaScript traditionally comes from the browser, which are notorious for like just like accepting crazy weird implementations. So it's probably less of an issue there. It was more an issue for us, but just something to keep in mind anyway.
Okay. So like, if people run into that, it's a dependency you don't control. Like, what do you do?
Yeah. If it's a dependency you don't control, you fork it. Like we have internal forks for some of the libraries that we use because we need like different behaviors that they just don't offer out of the box, and that's fine. But like, it's annoying. I wish we didn't have to. And I don't think like we try to upstream stuff when we can, but just sometimes the behavior is different. There's nothing you can do about it. Yeah, cool. So I don't think, like looking at these two, I don't think they're number one, either of them. Like I think we can do worse or better. So another one, which is sneaky, and I remember it, like I think from the 90s, I've like encountered it many times before, is that, so we have something that's called like the host header. So like when you make an HTTP call, you also need to pass a header that says host that kind of mentions, if you're connecting to example.com, it will say example.com. If you're connecting like someone else, it says something else. If I had to assume like the original reason why it existed is because you could have like multiple websites or multiple web servers on the same machine, and it needs to be like the server, the load balancer needs to be able to route it to the right place, like know which request is where. And you could probably use it for like other things as well. You can use it for localization. So like you can send it to the same server, but say, oh, this is the French version of the web page because it's like example.fr, and you can do interesting things there. I don't know why it came to exist, but anyhow, some implementations requires the host header to be the first line or the first among the headers. So if it's second, it's it just treats it as if it doesn't exist. The spec allows it to be anywhere. No, it fails. It just, oh, well, I'm expecting it to be first. It's not there. I'm going to fail because so
as soon as it doesn't see the host first, it just fails.
Exactly. So the HTTP spec says that every request should have a host header. And if there's no host header, return a 400, like return a bad request, at least for my memory of the spec. And they just, went a bit more strict and just said like, well, it has to be the first line and the first header. And, what we were doing was like very much within spec. But the world is ugly, the world is weird, and not everyone some people have different requirements.
Do you think they were actually being strict, or do you think they just didn't their implementation was kind of bad?
Yeah, I think
checked them all. It was just looking first. Yeah, I might not even realize that they did it. Right?
Yeah, when I said strict, I didn't mean strict in a good way. I meant kind of unnecessarily strict.
Mm-hmm.
Yeah, so that's again, that's another funny one. I don't think it's the worst one. It's just annoying, I guess I would say, but it's probably okay. It's just something you need to be aware of.
At least with these three that you've mentioned so far, is it easy to figure out that that's the problem, or can it be tricky to figure out what the actual problem
Very
is?
tricky.
When things fail.
So it always depends. The question, right? Is it a black box? Or is it not a black box? So what do I mean by that is that if you're able to talk to the other server and kind of actually go and talk to the people behind it and say hey, can we try a few things? Or hey, can you check your code? Then it's probably, the host one is fairly easy if you know what to look for. But if you don't know what to look for, you just get a 400 bad request. If they don't return the response, you have no idea why. And again, you can debug with them and you can see where it stops and where it fails, and you can try different things. But yeah, I guess the host one is, I get why you're asking. The host one is probably the most annoying one to figure out. The invalid header names, it would spacing the header name is easy. And the case sensitive is hard, but it's kind of manageable.
Gotcha.
Yeah. Cool. Okay, so you're ready for another one. This one is a bit more annoying.
Okay.
So nowadays, people use TLS, or formerly known as SSL. And TLS is great. It's a bit, maybe not great. Let me not take a stand, but essentially TLS is complex, and it supports, both upgrading ciphers and new cipher suites and all the cipher suites and kind of cipher negotiation. So you can the client essentially goes to the server and kind of negotiate on a cryptographic scheme that they agree on that they can use. So for example, I use AES, GCM. You do poly X whatever 2020 or whatever, I forgot the full name for whatever poly XChacha 2020 XChacha 20 poly 1305 or something. Yeah, sorry, I'm blanking.
Yeah, that's it. That's the one.
That's the one. Yeah, I'm blanking anyway. But my point is I support this, you support that. Okay, so we're not going to be able to communicate, but maybe there's one that we overlap on, and then we can communicate on that one. So it's kind of there's this whole negotiation on the right cipher to use. And that usually works because browser manufacturers have been great with making sure that everyone, updates everything all the time. And nowadays it's fairly easy to make sure that, the cipher suite on the back end is also up to date. And also, to be honest, it's not as if it changes every day. If you're using 5-year-old stuff, you're probably good. So it's mostly okay. But then you have people using old implementations or out-of-date servers and all of that, and you can have a clash. And the question is how strict do you go? Because you can say, and this is something we've witnessed, is that some of our customers were using, well, actually there are two parts, but some of the customers were using old cipher suites, and our library was just, or at least how we set it up was just, hey, no, we don't accept this. This is terrible. This is this is vulnerable. We shouldn't be no one should be allowed to be using it. It's terrible. And it's kind of the question is how strict do you want to go to not accept those, or how, maybe you should just acknowledge the fact that some people have weird or out of date implementations that are probably still secure, but just not considered maybe fully secure, as in like the NSA can probably crack it in a year, but normal people can't. I don't know like the exact like where to draw the line there. But they're just like different TLS ciphers, and you need to make sure that you actually, like follow the flexibility that you want, because you really don't control where the webhooks are going to be sent to, right? Your customers do.
Yeah.
So
yeah. I mean, to that point, there's also the threshold of like it just costing more than it's worth to crack it, right? Like that's a common.
Yeah, I'm very much of a security absolutist. Oh, sorry. Go ahead. Yeah, I'm very much into like security. So it's like very hard for me to like even go an inch there. But sometimes you have to realize that you have to meet your customers like where they want to be, without like not always like forcing people like to follow like the up-to-date best practices all the time.
Yeah.
But like another annoying issue that we've had actually is that, you know what, I don't remember it fully, so like maybe it's not worth mentioning, but I'll just like throw it in, is that the server was actually supporting a set of ciphers that we support, but it was just not offering them. So even though it supports some good ciphers, it actually offered shitty ones as like the list. And never mind, like going boring into negotiation. And then like the negotiation was failing, even though we could have actually like supported that. So I don't know if like that's an issue with the server or with the client. But what I'm trying to say, it can be weird. It can just be weird. And especially for us, like when it just manifested like as disconnects, like just like connection recent by peer. I don't know if it came from the server doing that, or if it just like, I think it's probably the server just like setting a reset packet. So it's kind of like a very weird thing to debug and realize. So maybe that does.
How would you even figure that out?
Yeah, so you just see a class. You see like this failure quite commonly, and then one thing I think that we realized is that one of those customers was using IIS, so like the Windows, like the Microsoft Internet Service, server. Sorry, and then we kind of like, that's interesting. I wonder if we can get like more IIS ones to like check it. And we're like, okay, fails there as well. And then we kind of like checked, like, okay, what ciphers does it offer? Like, or when we negotiate, which ciphers are being chosen? And we saw consistently the same cipher suite, sorry. And then like when we, looked it up online, we realized, okay, this is an insecure one. I was like, okay, that's probably because we've been too strict. And then kind of like how everything fell into place. Yeah.
So in those cases, it's usually us, like you're saying, being a bit more lenient to allow it, as opposed to like getting the customer to change something.
Yeah, I mean, we can definitely get, the problem is, for us and then for people in general is that, when you send webhooks, you really don't have control on like who is using your webhooks and where and why. So it's kind of like, okay, I mean, we can get our customers to change probably, but like, can they get their customers to change or future customers to change? That is just like like a problem for them that I just, we don't want to burden them with.
Yeah.
But it also would be a problem.
It's not even like, it's not even a problem just for Swix. It's the problem.
Yeah, it's anyone sending webhooks.
Swix customers. Yeah.
Yeah. I mean, it's both Swix customers, but also if our customers were building it on their own, they would still have the same problem.
Yeah. The same considerations. Yeah.
Yeah, exactly.
Interesting.
So, like now this feels like a bad one. But so this is the number one, tentatively the number one, like the worst one. But let me get to the next few and then like see if we can do worse. So another thing that like, we noticed early on is that some of our customers were using basic auth. Like URL embedded basic auth. So how does it look like? You may have seen it before. It's kind of like HTTP, HTTPS, colon, // and then username, colon, password at example.com. Have you seen those before?
Yeah. I mean, doing some research for like writing different articles and stuff. Yeah, I've seen like basic auth, and is usually included in like various like authentication methods for a whole bunch of different services.
So the basic auth doesn't have to look like this. Like it can also like if you entered some websites and they can like have a pop up that says username and password, like a Chrome pop up, not like a thing. That is also basic auth. But anyhow, the point is that this is just something that exists and some people use. And the problem is that not all, HTTP libraries actually support that. And we've had it. Like Hyper doesn't support that on purpose, like the Rust one. So first of all, that wasn't fun. Like, in the beginning, like kind of like, why doesn't it work? But also, like even so we had to implement it ourselves. So kind of like parse ourselves, like use a URL parsing library, like using all the, like existing tools, but like parse the URL, get the username, get the password. And then kind of like related to that is the user, because it's part of the URL, you need to remember to URL decode it. So if you have like the password is A+, then it would actually, like when you get it, it will be like A, %2D or whatever. Like, I don't know what the plus hex code is. So it's kind of like, okay, so you need to remember to do URL decoding.
You don't know the hex code, Tom? Come on.
Yeah, no, I mean, it's been, I haven't been fiddling with bits in a long, long time. So, but essentially, like, you have to deal with that. And then you kind of like, okay, what happens if the username is empty? Is that allowed? I have no idea. Maybe it's allowed in the spec, maybe not. But it's definitely something that we had to deal with and something that we did have to do. Like, so handle empty username, handle empty passwords, and kind of like make sure that you do that. And then like to do the basic auth, you take the username, you take the colon, you take the password, you base 64 it, and then you put it like in the authorization header. Again, like all of that we needed to do. But some libraries, by the way, will support that. So like I think, like Python requests would probably support that. But if you're going, because we've been doing like so many adjustments to our, to like our HTTP webhook sending like library, I guess we kind of like we went very low level, but that's another thing that we had to deal with at some point.
Actually, this is something that I was thinking when you brought it up and you said that Hyper purposely doesn't support. That's like they're taking this point of view that they don't want to and that they're not going to.
Yeah, exactly. So essentially what they're saying, Python is very opinionated, by the way, like as a project. But what they're saying, and maybe rightfully so, is like, hey, we're low level. You give us something, we send it. We don't actually go and parse the URL and like build this authorization header for you, like all of that, which really honestly makes sense. Like I get that. Mm-hmm. I wish it was more obvious to us when we started, but it's fine. So that's just like one thing to keep in mind, especially when you're doing low level stuff. And I guess like another reason why we had to do low level stuff, and is that, like when you send webhooks, like one thing that you need to worry about is like server-side request forgery. I don't remember if you and I, we covered it in like the architecture video. Mm-hmm. So essentially what it means is that because your customers just go and like add random URLs to your, to make you send webhooks to, they can essentially, instead of pointing it out to like example.com, they can point it to, like internal HR system, whatever. Or like you can just scan your network by just like putting like a lot of different like URLs and like trying all of them. And that's not good. So like what you want to do, and we covered it back then, first of all, you want to make sure that your webhook workers are in different VPC. But the other thing that you can do, or in addition maybe, is what we do. Again, we do both, but like what we do is we kind of like make sure that like our HTTP library doesn't make calls to disallowed IP addresses. So like if you're trying to make, any calls to any private subnet, it will just fail and block it in order to block like server-side request forgery. So we really had to go like, very low level to like protect against that. Again, there are other solutions. You could have used like a proxy that's isolated in its own VPC. You could have done like all of those kind of things. But this is like one path, but this kind of like forces us to go at low level, because it's not, like there are like a lot of bad ways to implement this. Like one bad way, for example, which I'm sure like a lot of engineers kind of like think, well, I know how to do it. I'm gonna just like make, how do you call it? I'll make a DNS request just before passing it to the HTTP library. So I'm going to like make a DNS request, check the IP, make sure the IP is good, because like you need to, if you're sending a webhook to example.com, like there is no, like you need to figure out the IP address. No, it's not local, because even if it's example.com, it can still be mapped to 127.0.0.1, like localhost. Sorry. So like DNS can like let you map it to whatever IP that you want, internal or external. So essentially you need to like resolve the IP and only then do this filtering. But and what people may be tempted to to do is kind of like resolve the IP, check it's okay, and then tell their HTTP library make a call to example.com. The problem is that it actually can be exploited, and so the DNS server can just respond and say like, okay, the IP is 1111, but don't cache it. Like this IP changes a lot, so like don't keep a memory, like don't keep a copy locally. Just like cache it for like 0 seconds. And then when it gets the second consecutive DNS request by the HTTP library, it will return, like 6660. I guess like the number of the beast is probably like a good example of like a bad IP. Yeah. But it's kind of like, and that's the point. So like that's not the right way to do it. So you really have to go internally into the HTTP library and make sure that you like override the resolving of the IP in order to make sure that you actually block it. Or use a proxy or use any of those other methods. That was a very long tangent of just saying like you need to go very low level to like make sure you protect against that. Mm-hmm. Yeah, and I guess the last thing. I mean, I know this is, this call is like dedicated to HTTP oddities, but there's like another honorable mention that is, like kind of like worth including. Because it's like webhook specific. So when you like one of the common ways of like doing, like when you protect webhooks, so like to kind of like authenticate webhooks, is to sign the payload and then pass a signature in a header. And then this way, like the receiver, the consumer can just go and like check the payload and verify the signature matches using the secret that they already have and verify that everything's okay. This is great. The problem is with, like with cryptographic schemes like this is that they're very sensitive to even the slightest changes. So like one additional space, so like one reordering and the signature is going to be completely different. So when you do that, you have to make sure the payload is exactly the same. And like one thing you can easily do by accident is, serialize it to a byte array, calculate the signature, and then take this like JSON object and send it to the library, like get to the HTTP library and say, hey, send it JSON. So, and then this library is going to like serialize it differently, potentially, than how you just serialize it when you sign the signature. And you're going to have like two different signature, like you're going to have a different signature than the payload. Right. Because like you use two different payloads. Does that make sense? Or was that very confusing?
No, I think, it's because the hashing algorithms are obviously extremely sensitive to like the smallest changes. So
by design,
it's like, it makes perfect sense. You add like a trailing space, right, to something by accident, and it's just, obviously it's not going to verify.
Yeah.
And like, should, right? The payload's not the same.
Yeah, no, exactly. That's works as intended. But the problem is that you have a lot of people, first of all, on the consuming side, they kind of like, we see it a lot. They first load, because the framework loads the JSON into like a JSON object, and then they try to serialize it and then check the signature. And in some languages, that serialization is not deterministic. Like it could, vary, it could just like vary depending on like how it was sent over the wire. Like, like a hash table may not have the keys sorted necessarily. And that is causing issues. And that's like something that, first of all, you can get wrong within your own code, but definitely on the consumer end. And that is a pain to discuss. Like, I mean, okay, now we know that like when people ask about it, it's like 95% that's what's going on. But sometimes it's like a pain to understand that this is actually what's happening.
And then how do they resolve that?
Yeah, I mean, you just make sure to get the row bytes as sent on the wire rather than kind of like let the framework parse anything or anything like that.
Okay. So it's like do the hashing before the parsing.
Exactly. Yeah. Yeah. I mean, again, the way you just put it sounds like very simple, but sometimes you have to like fight with the framework.
Easier said than done.
Yeah, I mean, sometimes you have to fight with the framework and they're like, no, I really want the row.
Please don't.
Yeah, don't pass it, don't reorder it, don't do anything. I just wanted the wait.
Yeah.
But
I mean,
by the way, we have like
that's super. It's super simple, but like I get that a lot sometimes in like Excel too. Like Excel, like when you're doing something, it like automatically like applies its formatting, and sometimes it's like extremely difficult to get it to stop.
Yeah, happens.
That's what it reminds me of. Yeah.
Cool, but I think this is it on my end. So if I had to choose, the worst one was probably, which one did I say? Like the host error first or the TLS ciphers?
No, it was the ciphers. It was the ciphers.
Ciphers.
And that one,
Yeah.
I mean, I think you also gave the longest explanation of it as well.
Yeah, because that's like it's a bit more complex. But yeah, I mean, I guess the ciphers, when you just send back like a connection reset by peer without like saying what's going on, it's the most annoying.
But it's, I guess, I mean, just like listening to you talk about them, it also seems a lot about like how easy it is to fix, right? Like how easy it is to identify that this is actually the issue.
Yeah. Yeah, I mean, that is kind of like funny. All of these are very simple. Like, what's wrong. It's actually mostly fairly easy to fix. The problem is not fixing it. It's like, first of all, anticipating it, but also once you get, again, the bad TLS ciphers, oh my God, like connection reset by peer, like how do you even realize that this is what's going on? And that is the problem. Like, it's kind of like identifying those. And like, there are like a lot of them, and you need to make sure that you're compatible with, with all the weird stuff that's out there.
Okay. Yeah. So that was a fun conversation as well. And I think, there are a couple things obviously with like the cipher one. I didn't know that that's how it works at all, right? So that was like a lot of learning from scratch. Whereas like, with your last example, I had a little bit more background to understand it a little bit better. So yeah. Thanks, Tom.
Oh, cool. Thank you.
I think we'll probably be putting out more stuff. So just stay tuned. Thanks.
See ya.